Hey everyone, welcome back to my channel where we learn to be a better programmer. And in this video, I'm going to talk about recursion. Before we get started, be sure to hit that subscribe button and turn on post notifications so you don't miss out on future videos. Okay, so recursion is a topic that comes up in a computer science degree or any part of a programming curriculum. And it's often a little bit hard to grasp what's actually happening. All recursion is it's basically a function that calls itself until it hits what's called a base case, and then it starts returning a result back up the stack. So I'm going to actually show this in a very interesting way. I'm actually going to write the code for Fibonacci, which is a Fibonacci number. And then I'm also going to put a breakpoint at a key part of the execution so we can see what it means when the function starts to call itself, and then we can actually see what the values are at different points in the stack. Okay, so I'm going to implement the Fibonacci function, and now I'm going to have a main function, and then inside this main we're just going to system.out.println Fibonacci.getFib of, say, 10. Okay. All right, so that's really simple. It's very straightforward to write a recursive function. It's only 2 lines of code. But what we're seeing inside of this getFib function is we have what's called a base case, which is if this value is less than 2, then just return that value. If otherwise, we say if the value is 3, we return the get Fibonacci of 3 minus 1 plus the get Fibonacci of 3 minus 2. And we'll see what that looks like when we start looking at the recursive calls. Okay, so I'm going to put a breakpoint at this return statement. And then I'm just going to hit debug. Okay, and we're going to take a look at what this looks like. Okay, so we see that at this first call, we see at the top here that the value passed in the function is 10. And so it got past this if statement. And so that if statement was false, so it didn't execute. And then we see that the value of 10 is passed in to these 2 other Fibonacci calls, okay? And then the way we also look at the call stack is we look at it down here at this stack frames view. So in the main function, we saw that it called Fibonacci with, or get fib with a value of 10, okay? And then when we look up the stack, it said, it called get fib with a value. Okay, now we can step over this return statement, so that means we go to the next call, and then we see that the stack is now 2 frames in size. Okay, so it called get fib again, but we also see that the value inside of get fib is 9. Okay, so that means that we're actually calling get fib again, but with a new value called 9. New value, and its value is 9. Okay, so if we step over again, we see that our stack increases in size again. So it calls get fib of 9 minus 1, which is 8. And we see that our value is 8. So we keep going through, and we see 7, 6, 5, 4, 3, 2. Okay, so it's calling this function again with a value of 2. And so this value of 2 is then passed into get fib of value minus 1. Okay, so we pass that in, it's going to return 1, and then it's going to also call get fib of 2 minus 2, which is 0, and it's going to return a value instantly. So we should actually see our stack decrease based on the number of breakpoints, where our breakpoint is set. But know that there was actually 2 additional function calls that happened there. Okay, so we saw it decrease. And so this call to 4 is actually complete now, because we did 4 minus 1 is 3 and 4 minus 2 is 2. So, and we got those values back. Okay, so it took the sum of them, and that's the value we're returning up the stack frame. So we should actually see the stack frame decrease again to 6. Okay, so we saw that it decreased, but now it's going to have to call. So that means it decreased, or it finished its return from get fib of value, which is 5 minus 1, which is 4. And so now we need to call get fib of 5 minus 3. So you can see how, like, when you make a recursive function, it tends to have sort of repeated calls to similar numbers because of just the way this Fibonacci function is working, okay? So in order to speed up and decrease the amount of calls that we need to make to these functions, what we're going to do is we're going to do something called memoization, okay? So I'm going to implement a second function here, just an overloaded function version of getFib, and I'm just going to pass in an integer array called memo, okay? And so the way this works is I basically say if memo of value is equal to -1, then I want to set the memo value. I want to say memo of value is actually going to be equal to the sum of the recursive calls where I also pass in the same array. Okay, so I'm calling this the same getFib function in the same manner that I called this one up here, but I'm just passing in the same array that I passed in. And then at the end, I just want to return memo of value. So we're actually going to take a look at and see why this function runs so much faster. And it's very nice in IntelliJ. They show the contents of the array during debug. Okay, so actually I don't want to put the breakpoint here. I want to put it actually right here. And so inside of here, I just need to initialize an array. So if we're going to use our value of 10, like we did before, I just need to basically say int memo is equal to new int of size, say 11, because we need to, we're not doing something, we need to actually add an additional value to the array so that we don't get an index out of bounds exception based on our number 10. Okay, and then I'm just going to say arrays.fill of memo, and I'm going to pass in -1. I'm throwing -1 as the sentinel value because Fibonacci values can't be negative. Okay, and then I'm just going to call memo here. Okay, so let's just run the debugger again, and we're just going to see sort of what this looks like. Okay, so we have that first call, and then here we see our array. So there, from left to right, the indexes are 0 index. So 0, this is index 0, 1, 2, and so on. Okay, so as we call this function, we're going to see the stack start to grow, similar to how we did in our previous example. But what we will notice is that as we start to return this value inside of, so Fibonacci of 0, 1, 2 is already filled in, okay? And the way our logic works is if we only call the recursive function if the value has not been set in there, okay? So every time a fib of 2 is called, this if statement is going to fail. So we're just going to immediately return that value of 2, okay? So what that means is we're just cutting back all of those extra recursive calls that we had in the beginning. So if we go through that stack frame again, we see that it's calling it with a value of 3 again, okay? So we're going to see the so basically it's calling getFib of 3 minus 2, which is 1, and we're going to see that value get filled in. So we see that we have 1, that fib of 2 is 1, and fib of 3 is 2. Okay, so that value is now filled in. So whenever we see a fib of 3, we're just instantly going to have that value pre-calculated. Okay, so we have 4, and now we're going to get another fib of 2, and that's going to return instantly because we already had the value of fib of 2 calculated. So fib of 4 is 3. Okay, and then we keep going down the stack, and we keep seeing that our array continues to fill in size. So this continues to decrease on the number of recursive calls that we need to make. Okay, and we see here we are at value of 7, and we have this fib of, let's see, 2, 3, 4, 5, 6 is 8. So, you know, it just keeps going, and we just see that this stack tends to just decrease in size over and over until we finally get our final answer, and our stack is finalized, and we get this fib of 55 out for 10. Okay, so let's just help ourselves out. We're just going to have a value here. So it's going to be a static integer. Int counter is equal to 0, and we're just going to count the number of calls to get fib. So I'm just going to say system.out.println counter, or I'm sorry, plus counter. Okay, and so I'm just going to hit stop, and I'm going to remove our breakpoint, and I'm just going to hit play, and we'll see how many calls to get fib we had. So we had 19 calls. Okay, so that's just, keep that number in your head, and then we're going to do the same thing. We're just going to say system.out.println of plus counter. And we're just going to call the original recursive only without memoization. And we're going to hit play, and the number of iterations blows up to 10x what we had before, roughly. So we have 77 iterations of that same function. So if you can see that the power of memoization is that it makes recursive functions usable in a lot of contexts. Otherwise, it just wouldn't work out. Like if I tried to just make a recursive function call to say 19, well, not 19, say like 25, and we try to, you know, call this, you know, it worked, but like, look at how many recursive calls that we made. We made 200,000 recursive calls. But if I call it with memo, and I have to change this to 26, let's see how many calls we make. Nice, 49, right? So that's very telling. So recursion is a very cool and neat trick, but it only really is feasible to use in sort of a production and professional environment if you use it with memoization. So I hope you liked the video, and I hope this helped kind of explain a little bit of what recursion is, and also how to optimize recursion to be usable in a lot of settings. Okay, so I hope you liked the video. If you did, please feel free to hit that subscribe button and hit that like button so you don't miss out on future videos. All right, thanks.